The 4.9 more examples. Number one, we have a car traveling 50 miles an hour. When the brakes are fully applied, the brakes produce a constant deceleration of 22 feet per second squared. We want to figure out the distance traveled before the car comes to a stop. Okay, the very first thing you ought to notice is that you're given one speed here in miles per hour, but the acceleration is given in feet per second squared. You have to be dealing with consistent units if you're going to do anything. So what I would do here is I would take this 50 miles per hour and I would convert that to feet per second so that the units match up with the acceleration here. Let's see, the way to do that, there are 5,280 feet in 1 mile, and there are, in 1 hour, there are 3,600 seconds. Okay, 60 seconds in a minute, 60 minutes in an hour. So yeah, 60 times 60, 3,600. And so it turns out that if you work that out, of course, the units of miles on top and bottom cancel, the units of hours on top and bottom cancel, and so yeah, this is going to give you 50, or that's going to give you feet per second. And yeah, so if you do 50 times 5280 divided by 3,600, I get 73 1/3 feet per second, which I'm going to just write that as a fraction, so 220/3 feet per second. Okay, yeah, very important to have units, consistent units. Okay, now let's draw a little picture of what's going on here. Okay, so here is here is kind of the start of the problem when t equals 0. When t equals 0, we know that the velocity, so v of 0 is 50 miles an hour, but I'm going to write that as 220/3. Okay, that's the initial velocity. That's the velocity that the car is going before the brakes are applied. The initial position, s of 0. Let's just declare that this right here is position 0. Okay, so s of 0 is 0. Okay, the brakes are then applied. The car continues moving until it comes to a stop. Okay, so here's the point where the car comes to a stop. We don't really know when that t value, or what that t value is, but we do know that whatever that t value is, at that point v of t will be 0 because the car is stopped at this point. We really don't know what the position is at that point. Really, that's what we're trying to find. We're trying to find how far the car traveled before coming to a stop. That would exactly be, this s, this position. Okay, so there's the picture. You always start with acceleration. Right, a of t, the acceleration is -22. It is negative, it's a deceleration. And so that means, right, so I'm considering the velocity to be positive, and so therefore the acceleration has to be negative to slow it down. Okay, so a of t is -22, and it is a constant, right? That's how I know that. V of t is an antiderivative for -22, so that would be -22t plus a constant, but really the constant is going to be the initial velocity, which in this case is 220/3. Okay, so there's the velocity function. To get the position function, you just do another antiderivative. Okay, the antiderivative of -22t would be -11t squared the antiderivative of a constant would be the constant times t. And then, we do need to, there's, plus another constant, okay, which is really plus the initial position, but the initial position is 0. So this is plus 0 right here. Okay. Now, we're trying to figure out s of this t, s at the end here. So we want to figure out s of this t value, but we don't know the t value. So this is going to be a two-step process. First, we have to find the t value that the car stops. Once we find that t value, you can plug it into s to figure out how far the car went. Okay. You can figure out the t value when the car stops by realizing that at that t value, the velocity is 0. So v of t equals 0 means that negative 22t plus 220 over 3 equals 0. And that's a pretty easy equation to solve. 220 over 3 would be 22t. So t would be 220 over 3 divided by 22, which is actually 110 over 3. Is that right? No, that's not right. 220 divided by 22 is just 10. So 10 over 3, right? That is the time that it took for the car to come to a stop. Once you know that time, then you can plug that time into the position function to figure out how far the car went, or how far the car traveled before coming to a stop. So s of 10/3, so that would be negative 11 times 10/3 squared plus 22 over 3 times 10/3. And when I type that into a calculator, I'm getting about 122.2 feet. Okay, so really this is how far, so this is how long it took, this is in seconds, and then this is how far the car traveled before coming to a stop.